All right, good morning, everyone. This is Andy. It's also called DevOps Andy. I'm the DevOps candidate for charter manufacturing. Yesterday, actually, I was lucky enough to invited for lunch and learning session on Thursday. I will be in person to meet you guys all in the company. First of all, I appreciate the team who met and last week during the interview sessions. I really enjoyed the conversation. I'm looking forward to see you guys on the Thursday, which is March 16th. Before I'm going to the Thursday meeting, I decided to share my current work in my current organization. It's kind of proof of concept that I presented to my e-commerce team. In the future, we may apply the same work if it is required in charter manufacturing. If I lucky enough to get selected by hiring manager, obviously. So long story short, so this is kind of the POC that I'm going to share today. It's kind of providing solution to the e-commerce team, where we need to provide like cluster auto scaling and a part of the scaling strategy, as well as which is kind of the pros and cons and go not go decision. Suitability for the e-commerce platform in Foxconn. And first things at a, first at a time, right? So my current task is going to more detail on PowerPoints, but I will do some live demo as well at the end of the presentation. So when we talk about the GPU auto scaling, there are two part of the work. One is auto scaling of the actual pods, which is running on our Kubernetes. We call HPA. And second one is auto scaling of the physical GPU resources in our node group, which also called cluster autoscaling. Uh, One at a time, let me focus on the cluster autoscaling part, which is actually the GPU nodes in our Kubernetes cluster autoscaling group. In my in a very simple words, that a cluster autoscaling is like kind of the piece of the application which is running in our cluster. I'm a big fan of the Helm charts. I deployed cluster autoscaler to my cluster as well. Basically, cluster autoscaler will adjust number of the nodes in the cluster when actually pods having issues to the created because if there are no more resources available, pods usually in the pending states, or pods will be failed to schedule in by the Kubernetes master. In our case scenario, we use the G4DN instances. Basically, that's more of like GPU related worksness or DevOps. Working close with data science team. They're using the time and motion studies, so most of the resource will be GPU related. So there's the Sally workers. You guys see that Sally workers is kind of the e-commerce backend pods, kind of the open source framework for by Sally by Python, basically, kind of helping us to distribute the task and analyze the task, AI machine learning application, basically. Uh, so when more customers coming in, more resources required. So Sally worker nodes will be more pods will be needed for in order to consume the customers produce AI tasks. So we need to have some kind of strategy for scaling the nodes to the auto scaling group. So first step will be the cluster auto scaler will checking, oh, is there any pending pods? Oh, they say the one pending pods is over there. So cluster auto scaler will talk to the Kubernetes master kube system to provisioning the resources and add it to the auto scaling group. I just clarify that here we have a setting workers, which is like GPU hungry, memory hungry application and backend, which basically based on data science team, designed for SANI workers. So SANI workers, we utilize entire one GPU of the resources when processing a task. Therefore, SANI workers needs to be allocated one entire GPU resources, since we are not the big company for AI tasks. So we're just using the G4DN instances, which provide one GPU of resources, 4 CPU, and 16 gigabyte of memory. So in order to run more SADI worker pods, we need to add more, nodes in our auto scaling group. That's kind of the task for cluster auto scaling. And more AI tasks registered in the queue, it means static worker will be created in our auto scaling. So so Kubernetes massively managed all scheduling stuff. We're just making sure we have resource available. And this slide shows typical the node auto scaling up process. Static worker needed, we add more GPU resources or share. So when talking about the class auto scaling, there are two part of the work, right? One is, scaling down, one is scaling up. I just, this slide basically scaling up process. Of course, class auto scaling have a mechanism that every, certain number of time, minutes or seconds will check there's like, scale up needed or not. If not scale up needed, they usually, reduce the number of the pods resources basically. Unneeded resources will be removed from the auto scaling group. So this kind of the first slide I have. And second slide is I mentioned earlier, the class auto scaling will be two. One is class auto scaling. This is mainly focused on the horizontal pod auto scaling strategy that I provided to my team. So basically, this process more of like horizontal pod auto scaling. when more when more pods is required, it will be create more SATI workers. Basically, in this slide, we have like node one before HPA scaling. As soon as we, cluster horizontal pod auto scaling is enabled, so it will be more traffic is coming. It will create more SATI worker pods based on HPA setup. So this is kind of the hand in hand. DevOps team is responsible for set up the HPA for SATI workers to scale and also reduce number of the SATI workers based on the GPU utilization. I will go more details on next slide, I think. So what is the solution for this? How are we going to add more SATI worker pods? How are we going to add more nodes in a class auto scaling group? This is kind of the process I'm going to share. Basically, we have like in this slide, basically you see that like query the metrics. Where's the metric coming from? We are getting advantage of the DCGM. DCGM is like data center GPU metric server. DCGM is basically data center GPU manager. Basically, that's the metric server as well as GPU monitoring service that we is set up for the data science team in the system already. So basically, we will get the advantage of the GPU monitoring system that we set up for data science team. When we're using GPU, metrics, basically collect the GPU utilization. Uh, as soon as there are more like GPU utilization happen, like more than 80% of GPU resources are consumed, the second set of worker will be ready to, serve for the customers. So as soon as 80% of the set worker GPU resources are consumed. We have one more pods were created, but we don't have no resources here. So pod is in pending states. Class auto scaler we add the one GPU resource to auto scaling group. So this is kind of the whole the structure of how auto scaling works hand in hand. So basically we also have like replica sets available. We add more replica sets as well, like minimum, maximum replica sets. Um, that's pretty much the AWS provided best practices recommendation, process. Also, combination of the NVIDIA official documentation. They're also recommended using the Magic Server DCGM to, managing the GPU hungry application. So we just set up the best based on the best practices we have. I think that's covering both sides of the work of the auto scaling. What is the challenging actually here? Challenging will not be applied to the Kubernetes side as well as the upside. It's more of like development e-commerce application design process. Make sure the application architecture design as a cloud native microservice design. Otherwise, if Kubernetes HPA doesn't suitable for the application like monolithic application or doesn't have like microservice architecture design setup. So that's kind of the expectation for e-commerce dev team to make sure we are in the same page on this process. We also help the dev team to share our best framework that we're using for the GPU stuff. So that's the challenging part, and I think I'd like to share my chat. Basically, before uh, I'm doing any kind of the work, I need to share a plan ahead. Before going to the plan, I need to share my budget, a summary, budget expectation to my expectation for my manager, so he will approve my budget. So right now, my estimation for proof of concept is $35. Actually, I only cost EKS, Elastic Kubernetes Services, and G4DN instances, but because of time, I only use 20 hours, so it's roughly like $12. But class auto scaling will involve more GPU resources, so I just multiply by three, so I can end up $35 for this work. Uh, let's go for the implementation of the work. So, so as I said earlier, before I'm doing any kind of task, I need to create the clusters ready. Basically, create the HPA test cluster where I have a GPU node group set up. Here, added, I have set up desired is one, and I also have like minimum size is 0, maximum size is 2. It's based on your needs actually. I just since this is a POC, I just using maximum size of 2 nodes for G4DN instances. Also, I have to create some tags, making sure my monitoring system can capture the my GPU resources, accurately, as well as I have tags as well. Let me first save it, and then you will see the tag as well. Of course, this tag will be the class autoscaler tag to be enabled, as well as HPA. On top of that, I think I have to set up the whole like building the trust between the class autoscaler with autoscaling groups. So a lot of I need to create a role for it. I have to create a policy to attach to the role, as well as I need to create tag, as you guys see it. So before I'm doing the work, they have some prerequisites needs to be done first. So this is like a creating process, and for GPU resources. On top of that, I have another node group is called extra. Basically, this is more of like our monitoring system to be deployed on this T3 medium instances, like regular I think it's 4 CPU and 8 GB of memory, if I'm not mistaken. It's kind of things. I just give it 2 nodes, just in case my pods will be pending state because of resource. Uh, let's check it out, my HPA stuff resources. Okay, I think as everything's active. Let me go back to here. Let me check my pods. So this is my like Bastion host services. Let me go back here up. Okay. Okay. Let me go to K9s. K9s I use for, basically checking my, pods and all that, kind of the easy process, easy setup for me to managing my pods. So based on this one, I think let me check my HPA. Um, so this is my horizontal part auto scaling YAML file. So based on this, I created the video. This is kind of the horizontal part auto scaling like YAML file. Minimum replica I put at 2, and then maximum I put like 8. I can go more if I want to, but right now I use this one. And then metrics, target metrics, I use a DCGM exporter. So like NVIDIA DCGM exporter will monitoring the metric name, which is called DCGM FI dev GPU utilization. Based on GPU utilization, as soon as go, we reach 80%, it will be create more replica sets of the application I use. The application I use for this POC was like a machine learning GPU hungry application. I use this one from uh, this, NVIDIA Deep Stream Intelligence video analysis demo, which kind of NVIDIA provided using the Helm charts to deploy this stuff. Uh, so this kind of the apple to apple comparison in the future for Foxconn, e-commerce team do deploy the same kind of GPU video analytic application kind of for testing purposes. So let me deploy this CDL. I think it's HPA, and the namespace I use test as namespaces. Okay, I think HPA is ready. Yay. H, HPA. All right, so HPA is up and running. Right now, the resource up and running, but target is said unknown. Why? Because we deployed this deep stream application, but replicas that I set it to zero deployment. Basically, the application didn't deploy yet to our cluster. So let me do it one replica set at a time. Okay, so now it's a two-piece application will be running in 2 seconds. Let me check the other parts, what we have so far. Okay, looks like we have a cluster autoscaler with set up already. I use Helm charts. As I said, I'm a big fan of the Helm charts. Cluster autoscaler already there. And let me check my metrics and Kubernetes. Again, the cluster autoscaler is supposed to be in the kube system, the talk to the masters and all that. And then we have a DCGM exporter also running. I think is right now is DCGM exporter still pending states. Yeah, it's running right now. DCGM exporter, the metric service I'm talking about. Okay, continuous right now is creating for like video analysis. I go to namespaces to check it off. My bad. Right now is pending states is creating more, the analytical applications. Let's wait for a second. And before I'm going to, I have to check my, the metric setup successfully or not. I just create this one and check. Okay, based on my metric server, it's all there, like GPU utilization, memory utilization already there in my system. So metrics are working fine, which kind of prove that how it works. Right now is two. Another application is running, another one is pending. Okay, the four of is running right now. So, which is kind of proving that, we are able to set up the auto scaling. We also kind of helping to set up the HPA wall through YAML file. And okay, so 1, 2, 3, 1, 2, 3, 4, 5. 5 of them running at the time. DCGM export already there. So this is kind of the proof of concept. Let me check it out, my resource consumption as well for each pods, see how much resources are using it right now, or HPA. Is that targets? Right now, we set up target for 80, as you guys know, but only 44% of the GPU resources utilizing. So currently, basically, no traffic is coming yet. I'm going to working on to create more traffic in my next demo, basically, based on the, in order to using the HPA work, we need to have more traffic coming in. So based on the traffic, we have more HPA working replica sets, and then the cluster auto scaling will be, working as well in here. So currently just still one because no traffic coming in. More traffic coming in, this is gonna be up to 2 nodes will running. So this kind of the hand in hand with HPA. All right, so that's my presentation for you guys, and I see you guys. I see you guys on Thursday. I hope you guys like my presentation, and I will receive more feedbacks if you guys have any feedback for me. Thank you so much. I hope you guys have a wonderful day ahead. Take care. Bye.